You have fallen into Event Horizon with John Michael Godier. In today's episode, John is joined by Fraser Cain, creator and publisher of Universe Today, one of the world's largest portals of space and astronomy news, with over 140,000 subscribers. In 2006, Fraser joined with Dr. Pamela Gay to create Astronomy Cast, which is among the top-rated and most popular podcasts in the natural sciences. Remember to subscribe to Event Horizon so you never miss an episode.
Fraser Cain, welcome back to the program.
Glad to be back.
Fraser, we have had a busy year so far in both scientific discovery, but especially in rocketry. The last year has been amazing because we have seen the return of Saturn V class rockets, two of them, and both have launched, Artemis and Starship. What's going on with Starship? Now, when is the next launch, test launch, and what's the next one going to do?
Yeah, so there have been 4 test launches of Starship in varying levels of success. And were these successful flights? People will argue for hours about whether or not the previous flights have been successful. But the most recent version launched about a month ago, and it lifted off successfully. One of its engines failed on the Super Heavy right from liftoff. It reached its maximum dynamic pressure. The Starship detached. The Super Heavy kicked off. It's got this ring, this hot fire staging ring in between the Super Heavy and the Starship. Ejected that. This is sort of a temporary design that it will eventually go back to not ejecting any part of the rocket, but this thing weighs like 10 tons. And then it flew. The Super Heavy did its boost back burn and then landed gently in the Gulf of Mexico, fell over sideways, broke apart, and sunk to the bottom of the Gulf of Mexico. But apart from one of its engines not firing, every part of it seemed to have gone perfectly well. Starship continued on into space, and it didn't do anything. Like, it had no mission. It was just to successfully return into the Earth's atmosphere. And last time, with test number 3, there was clearly something very wrong. It was struggling to change its attitude as it was trying to make its way back into the atmosphere. This time around, it was locked on. It was exactly at the right angle that it wanted to be, re-entered the Earth's atmosphere. And as it did, we saw the ionized gases building up around the outside of the rocket. As it was still getting sort of thicker and thicker through the atmosphere, it was like we could see hot gases starting to melt their way through one of its maneuvering fins. And incredibly, we were able to maintain this lock on the rocket all the way through the atmosphere. And it sort of re-entered the atmosphere above the Indian Ocean. As it sort of made it through the bulk of the atmosphere, went into a free fall, and then just before it hit the water, it reoriented itself and did a sort of its own retro burn, came to essentially a stop, and then fell down into the ocean and flipped over, and also was likely now at the bottom of the ocean. So on the plus side, it survived, and it was able to control its descent and control its landing, as you would say, gently in the water. On the downside, there was clearly catastrophic damage going on to the steering fin, to parts of its heat shielding. It would not be rapidly reused. Like, if this was the mission, it would not be ready to go in any time soon. But it demonstrated that they're in striking distance of having a fully reusable 2-stage rocket. So the plan next time, the 5th launch, and it's probably within about a month from now, probably by the end of July, we should see the next attempted launch of Starship. And this time around, they're going to try to launch and catch the Super Heavy on what they call Mechazilla, these giant chopsticks, the launch complex that actually where the rocket launches from. The hope is that it will be able to boost back, get grabbed by Mechazilla, and be held safely. And then in theory, they could then use this first stage booster again in the future. No plans to try and reuse the second part, but who knows? Maybe they'll give it some kind of mission, some test payload. We don't really know what the plans are for Starship. But based on what happened with that first mission, they're going to be, they've made a pile of changes to the heat shielding, the way they're protecting the flaps, and the hope is that it can return to Earth with less damage this time around and move towards that idea of a fully reusable two-stage rocket system.
This also seemed to usher in the age of pretty re-entry footage, because that's always been an issue, getting through that ionized plasma, getting radio through that, now you just lose contact. But with Starlink, we finally got some good footage of the plasma of re-entry. I was very impressed with that. What did you think?
Oh, yeah. I mean, this is such a trope in rocket media, like Apollo 11, Apollo 13, things like that, where they lose contact. Like when the hot gases start to envelop the spacecraft, you get this ionized region around that blocks radio communications. And so they lose contact with the spacecraft. At the time when the astronauts are going through the most hazardous part of their return journey, they lose contact. And so you have to wait with bated breath to find out if they survived the reentry. Well, against all odds, Starlink was able to maintain a rock solid communications with the rocket as it was re-entering the atmosphere. We got a couple of drops of signal, but just for seconds. And really the big problem was that the hot gases covered the sort of blue soot and smoke into the camera lens that obscured our view to be able to see what was actually going on. You just had these tiny little windows through the soot that you could see what was actually happening. But the communication was solid the entire way through. So hopefully the soot, the camera, I guess the spacecraft melting problem will be sorted out. And so we should be able to see the full reentry all the way through.
That in itself was interesting, though, because you could see a little window towards the end of it after the fin was badly damaged and it was down there, but you could see it maneuvering just barely.
And sparks coming off of it.
And everything else. And I was like, this is the most visceral spacecraft failure that, unmanned anyway, that we've ever seen, and that it just was just amazing. Yeah. And that's got to be priceless for engineering data for SpaceX, just having that much.
Yeah, I mean, it's almost as good as them actually being able to recover the spacecraft and pull all of it. Because, like, the spacecraft is a giant computer that is recording data on all of the sensors, the positions of all of the fins, the positions of all the internal temperature sensors, all of the pumps and tubes and all of that. Everything is being recorded. And because they had this high-speed connection with the Starlink network, they were able to dump all this data out so that they could then go over and analyze it. And so, yeah, if they had lost contact from the moment it went into reentry and the ionized gases started to envelop it, then they would have lost so much of that information at that critical point where those flaps were starting to be severely degraded by the hot gases from reentry. And yet they were able to get every part of that. And so, they kept saying beforehand that the payload of this mission is the scientific data, is the information about how the thing went. And they got it, right? They got their payload. They were successful on that front.
I have to wonder, with those coming down into the water in a soft landing, this is very different from like Apollo, where, I don't know if you recall, but Jeff Bezos a number of years ago went and recovered some of the Apollo engines off of the ocean floor.
Yeah.
And obviously those things hit at very high speed, and they were just damaged, but still recognizable, but they were damaged, missing their bells and all that. With these SpaceX ones coming to a soft landing, I wonder if they're intact on the ocean floor.
Yeah.
And if somebody someday will go and salvage them.
Yeah, I don't know. Probably like after we did our video on the launch of IFT4, every second question was like, did it float? Could they grab it? Could it, couldn't they have rescued it somehow? And the answer is no, that super heavy, these spacecraft are designed to be structurally stable when they are vertical. They are not designed to be structurally stable when they're on their sides, when they have kind of And when you think about the height of the spacecraft, it is hundreds of meters tall, and this thing is falling over sideways. It is hitting at incredible velocity as it's crashing into the water. which, everyone tells you, hitting the water is not soft. And so the thing kind of crumpled and would have broken up in gashes and would have filled with water and would have just gone to the bottom of the ocean. But you're exactly right that it's not the same as the thing hitting at 28,000 kilometers per hour or some higher velocity or detonating from a launch failure. And so they're somewhere down there. There are 2 new wrecks that some deep sea explorer can try to go and find.
500 years from now, they'll recover Elon's rocket.
Yeah, exactly. Yeah. The future version of the hunt for the Titanic. Someone's going to be doing a documentary about the hunt for Starship.
Could happen.
Yeah,
could happen.
Yeah, I'd watch that.
Actually, almost certainly would happen eventually. Because the older something gets, the more interesting it gets.
Yeah.
Now, Fraser, the whole idea of Starship, as Elon Musk laid it out, is to go to Mars and found a Mars colony. But what are the other uses for such an enormous heavy lift rocket? I mean, what can we do with this thing other than Mars?
Well, right now, I think the best answer is that we don't know. The most obvious use for Starship is to launch Starlinks. And so SpaceX has been designing a newer version of the Starlink that is sort of a beefier version that can only be launched in Starship. And so they've been waiting to get this thing operational so they can start launching Starlinks, the version 2 of the Starlinks. And they have, say, 6,000 Starlinks today, but their plan is to get to 40,000. And so they could easily fill their own launch manifest with Starlinks for a decade to come. So that's the short answer. The short answer is this thing's going to be used to launch Starlinks. And, now SpaceX is starting to test communicating with Starlinks with people's phones. And when they get to that full operational network, it's very possible that you could not have a cell phone provider. You just use Starlink. And then wherever you are, anywhere on Earth, you just make phone calls and receive data and send text messages. And it's all under one plan. And you give your money to SpaceX as opposed to AT&T or whoever your service provider is. So that's the direction this is all going. Plus, they're making smaller versions of their dishes that you can take them backpacking now. There's versions that go on to ocean liners so people can have high-speed internet when they're on their cruises. So, at one point I looked it up that like the worldwide telecommunications industry is a $10 trillion industry or something like that. So there's an enormous business opportunity if SpaceX can grab big chunks of this. And that alone will fund the development and launch of Starship. But they think that that this spacecraft will bring the launch cost down by multiple orders of magnitude. So if right now it costs, say, $2,000 a kilogram to launch a payload into low Earth orbit on a Falcon 9 rocket, maybe it'll be down to $200 a kilogram, maybe $75 a kilogram on Starship. That, because you've got a fully reusable 2-stage rocket, the only cost is the fuel. Now, they've said that before. They've said that they were going to bring down launch costs by orders of magnitude, but NASA is still paying them $60 million per seat to launch astronauts to the International Space Station on the Crew Dragon. So costs come down, but they don't necessarily come down that far. But if they do hit that sweet spot that they're hoping for, then you will have per pound the cheapest launch method is Starship. So it will be as cheap to launch a 1,000 kilogram payload as it is to launch the full 100 tons reusable that Starship is designed to do. And so it could end up being that it just gobbles up the entire launch market. If you've already potentially contracted to launch for 100 million to launch on one rocket, now you do it for 10 million, now you do it for 5 million, like that gets pretty compelling. And there's something to be said for just enormous payload capacity. When you look at James Webb Space Telescope, the majority of the cost for that 10-ton space telescope was to shave down the weight on the primary mirror, on the sunshade, on all of the connecting booms and parts that brought this whole thing together. If if they could have launched on a more massive rocket, they would have saved them a lot of money because they wouldn't have had to develop that. So instead, if they could just launch in a, say, make the thing 50 tons and just launch it on a Starship, that would have been a lot cheaper for development. So right now, we really don't know, because we don't know how the whole thing is going to shake out. What is the level of reusability? Are these things going to be rapidly reused? What is the cost going to be? We don't really know. But if it does end up in some regime, as SpaceX is hoping it will, then you're going to see satellites and space telescopes get bigger and simpler. They're going to be much more like someone just took the very large telescope, put it in a box, put it inside Starship, and sent it into space, as opposed to these finely crafted, gossamer space telescopes that have been built up till now.
I think one of the things that also interests me about these giant rockets is it makes the outer solar system more accessible. You know, you can get higher energy launches and get out to Jupiter and Saturn much faster than
especially with refueling.
Yeah, especially with refueling.
Yeah,
and I think that's unexplored territory, but it's there lurking.
Yeah,
and that changes the profile of space exploration.
I am a lot less enthusiastic about the potential for sending an enormous number of people to Mars. I am downright ambivalent. If a person can be so, which is like Mars. You know, we've talked about this in the past. Mars is horrible and dangerous and deadly, and the people who go there are going to be struggling for survival. And we don't need to send 1 million people. We need to send 5 who are going to teach us what it takes to survive on Mars. And we're going to have versions of that for decades as we hammer out and learn lessons and push through the various disasters that are going to happen one after the other. It is not like going on a rugged survival trip into the desert. It is a place that is airless, that's filled with radiation, with low gravity, that is trying to kill you in every way that it can. And so for humans going to Mars, that doesn't feel like, it feels to me like we're going to be looking at a fraction of the overall launches ever carry humans to Mars. But you're exactly right that there are so many missions that have been proposed: a mission to Neptune, a mission to Uranus, a mission to the solar gravitational lens, where the problem is that you just need a heavier rocket than exists. And if you take a Starship and you launch it into space and then you refuel it in space, you have enormous amounts of delta V that you could then take. You could chase down Oumuamua if you wanted to, right? And rendezvous with an interstellar object. So what were pie in the sky targets suddenly become available for scientists.
And that's important because, you know, the decadal survey, the last 2 have, you know, prioritized Uranus exploration, and it didn't get done. And now there's talk, but, you know, we don't know yet. But the fact is that planet is weird. You know, there are many, many weird aspects about Uranus, and it sits in obscurity. And yet, if we do send a mission there with what we're looking at right now with rockets, it's going to take years and years to get there.
Yeah, 10 years.
But with Starship, no, they might be able to do it a lot faster.
Yeah.
Do you think that about, you know, your point on not sending very many people to Mars, and I don't think this is going to be the Normandy landing here either. I don't think that there's 1 million people are going to go do that. I think it's going to be an Everest, where some people decide, okay, I want to go and summit Mount Everest, but most people don't.
Yeah.
And I think it'll be one of those things. What I don't think it's going to be is profitable. And I wonder if by creating his giant Starlink empire, that's where the profitability comes from, and Mars will always be a loss leader. Do you think it could happen that way?
Yeah. I mean, like, I think that Starlink is going to fountain money, and then they can figure out and decide what they want to do with that. And if people, you know, they'll come up with because this was always the plan, was to send humans to Mars. And I think Musk had said, it's going to cost about the amount of a house. Like, if you want to spend a couple of $100,000, you'll be able to go take a one-way trip to Mars. And so maybe that'll still be the case, that people will be able to pay a couple of $100,000 to take a one-way trip to Mars. But I think it'll be more like people who take the adventure to the International Space Station. They pay $50 million to spend a week on board the International Space Station, or they spend, I don't even know what the Polaris people are going to spend doing their orbital flight with their spacewalk. So I think it's going to be in that kind of realm for the foreseeable future. And I think you're exactly right that there will be occasional billionaires who take a 2-year journey to Mars and back.
You know, that reminds me about Dear Moon, which was canceled.
Yeah.
And that was originally going to loop around the moon and come back. But it shows that delays in time and all of that stuff gets a lot of this stuff canceled.
Yep.
So space tourism also suffers from that problem.
Yeah, I mean, there are so many projects. There was another moon, a Mars, sort of crowd-funded Mars project that went under. There's been any number of these. And I don't know, it's because we're so far away from this being a reality. I mean, in our minds, science fiction has told us that we're just right around the corner from this being a possibility. But the reality is that there are just so many unknowns between here and there that have to be worked out. And until they're worked out, like, we don't even know if the human body can survive on Mars for long periods of time. We don't know if it's safe to gestate human beings in 1/3 Earth gravity. There's just so many unknowns, right? So really, you'll know that humans can go to Mars when there's been a pet cat on the moon for a couple of years and it's had babies, right? So, I just feel like we are still decades away. We are decades, if not centuries away from the dream that we're being sold through this kind of science fiction interface with space exploration. And I think it's that same frustration that the previous generation had with the Apollo landings. They saw humans set foot on the moon in 1969, and they're like, that's it. Our Star Trek future has arrived, and here we are 55 years later, and we're now a couple of years away from humans returning to the moon and haven't been there for half a century because it's hard and it's expensive and it's complicated and there are other priorities. And you're going to see this as well. So if you're excited about humans going to Mars, be patient. I've been reporting on these plans for 25 years now, and I don't feel like we're close.
I don't think we are either, and not to be a pessimist, but I seriously wonder, and this has been brought up out there before, that it won't be us as Homo sapiens that actually colonize Mars. It'll be a GMO human that is built to be able to reproduce and function on Mars. And that's something we may never do. We may never take genetic manipulation that far for ethical reasons.
Yeah, and I think we've talked about this in the past, that Mars sucks, and that when we finally internalize that Mars sucks, in kind of the way that Antarctica sucks. Like, you are free to go live on Antarctica right now today if you want. You could just go to Antarctica, find a little cove, and build a little shack, and you could just live there. And it's not strictly legal because there is no, there's no ownership of any land in Antarctica, but who's going to stop you? Well, what's going to stop you is the severe, terrible environment of Antarctica is going to stop you. And in the beginning, you're going to be all excited and think this is just the greatest thing. I'm a pioneer living in this harsh landscape. And then after a while, you'll be like, I'm hungry and I just want to be warm and I want to go home. And I think that's just what Mars is going to be like. That at its absolute best, all that Mars will give us is hardship and make us long for planet Earth, with its warm temperatures and inviting oceans and gentle rains and interesting wildlife. And so I think it's going to be a long, long time before we have trivialized living on Mars in the way that we've trivialized living in a place like Phoenix, Arizona. It's like 5 million people that live in Phoenix, and that's possible because of air conditioning. And without air conditioning, you just wouldn't have that kind of population in Phoenix. And so it's our technology that trivialized that existence. And until we have that, and that's some kind of future science fiction technology that we just don't have today.
The Antarctic emperor penguin feels the same about Phoenix as you do about Antarctica.
Yeah.
That goes to show you that something that's adapted for it, like you would adapt a human from Mars, changes the game. But at the same time, do you want to start, really, really modifying humans?
But, right.
Especially with childbirth.
Yeah, but you take a penguin to the actual South Pole, and it will not be a happy camper. And that is still dramatically more habitable than Mars. So, and the kinds of changes that you're talking about, like you cannot make a human able to breathe and exist in 1% of the Earth's atmosphere made of carbon dioxide that can withstand 200 times the radiation hitting their body. We don't, maybe the gravity, the 1/3 gravity is something that can be overcome. I don't know. So it's really hard for me to believe that we will go let's make all of these incredible sacrifices so that we can live on this world that sucks. But when just zero gravity space stations, O'Neill cylinders are just waiting for us to set up shop.
And that brings us to the next billionaire, Jeff Bezos,
right?
Who is as a student of Gerard K. O'Neill back in the day. Bezos still has those ideas of people living and working in space habitats. How much closer are we to an O'Neill cylinder than we are to a Mars colony?
Are you asking me what's the state of Blue Origin's rocket factory?
Yes. What is their state of their? When are they going to get their giant rocket operational? But they're making money because they're selling engines, so they've got something going.
Yes,
along with the the tourism and everything like that.
Right. So Blue Origin, this was founded, as you said, by Jeff Bezos, and it was founded around the same time that SpaceX was founded, maybe even a little before. But unlike SpaceX, they have been doing all this work in secret, and apart from sort of developing a suborbital rocket system, the New Shepard, and taking some tourists on some tourist flights, they really haven't done much on the orbital side. Now, they have been working on their New Glenn rocket, which feels like for 1,000 years. And we still haven't, we've seen glimpses of it. They gave us some pictures of their New Glenn being sort of put vertical. We've seen the fairings. And in theory, this rocket will be capable of delivering, I'm going to say 60 tons to orbit. And we'll have a reusable first stage and then a disposable upper stage. So it won't be the full reusable like Starship, but it'll be more reusable than Artemis. Maybe it's 40 tons. Anyways, one of those numbers, 40 tons or 60 tons to low Earth orbit, compared to 100 tons for Starship and 95 tons for the Space Launch System. And in theory, we're going to be seeing a test of New Glenn later on this year, but we've heard that before. I'm no longer in hype mode for anything that Blue Origin is doing. I'll just wait for them to demonstrate things, and then I'll report on them when they happen.
Anything in rocketry, though, it always slips.
Totally.
I mean, just,
you
expect it.
It's rocket science.
Yeah, it's rocket science.
Yeah.
And I just like that there's a competitor that's thinking in a different grain, more towards again, habitats in space and the moon, that kind of gives us, one company's focused on Mars, one company's focused on the moon. And then we get to Artemis, which has successfully launched. And it was, it launched before, I believe before Starship did, at least orbital or whatever it did.
Yeah, launched back in late last year, October, November.
Yeah, late last year. And that was the most impressive rocket launch of my lifetime, because I came along after Apollo, and there was no Saturn launches. And that was actually the largest rocket I've ever seen launch, and it was spectacular, especially with those
it really was.
boosters.
In fact, it was spectacular in the damage that it did to its launch platform. So it tore apart chunks of its own launch gantry. They've had to go back and reinforce it. It was more rocket than they were expecting.
Yeah, that seems to be a common theme too, because remember the Starship just completely threw concrete chunks out into the ocean.
Yeah.
Crazy. But now channel back to the 1980s with me, if you will. When we just had the space shuttle, and then the space shuttle got retired, and then we had nothing. And now it's just so different. so different. So how does that make you feel as a lifelong space enthusiast that we really do seem to be back in the game as far as rocket power?
It's a really funny time, because my answer to this question would change a year from now, I think, or 2 years from now. Well, where we are right now today, the Space Launch System is a very expensive rocket. It's probably going to cost about $4 billion per rocket, and independent auditors are pretty sure that there isn't going to be enough funding to maintain this program in perpetuity. And it is a design of like an older era. It is, as you said, it's the Apollo era type of rocket, where you're taking these beautiful engines, these RS-25 engines that were designed for the space shuttle, the Lamborghini of rocket engines, and you're destroying them in the ocean, not reusing them in the way they were originally intended. So it's this disposable thing, and yet it's a gigantic rocket capable of lofting 95 tons to orbit, of carrying the Orion capsule to the moon. It's a wonder of modern engineering. And yet it doesn't feel like it's really that sustainable over the long term. And yet, in theory, we're going to see the next launch later this year. We're going to see humans on the moon by 2026. That'll be really impressive. And you compare that to what's happening with Starship. I mean, you've got the potential for a fully reusable two-stage rocket where the whole thing is going to launch, and then both parts will be reused. All they have to do is refuel them in the way you refuel an airplane or your car. That has the potential to bring cost down, but this thing hasn't been proven to fully work yet. And then you've got other options. Who knows what's happening with the Chinese? They're planning on sending humans to the moon by 2030. We talked about Blue Origin and their New Glenn rocket, which we should see a test later on this year. And if so, we'll start to take over a big chunk of the launch market. United Launch Alliance is in this weird place in between rockets. They're shifting over to their Vulcan platform, which has levels of reusability. Arianespace just tested their new Ariane 6 rocket, but it just is a blast from the past. I mean, this is a fully disposable rocket capable of launching 20 tons to low Earth orbit. So not the same class as these heavy lift vehicles. And so the future is unclear right now. Will SLS continue on? We don't know. Will Starship work quickly? We don't know yet. Will New Glenn be tested? We don't know. Will the Chinese land on the moon? We don't know. So everything is just like totally up in the air. And I've felt really unsettled and in limbo now for the last probably 2 years as I've been attempting to report on all this stuff. And people are always like, what's going to happen? How's it going to work? Who's going to win? I don't know. I don't know what's going to happen. It's too soon to tell.
Too soon to tell, but it's too soon to tell in a good way, just because there's so much happening.
Yeah. Yes. Yeah. It feels really dynamic. It feels like there's a lot of paths that are going to get us to that destination, and we just don't know which is the one that's going to pay off in the right way. But hopefully one of them will.
Well, I think one that's almost certainly going to pay off is Vulcan with ULA that you mentioned. That seems like an eminently useful exploratory rocket for NASA to replace ULA's previous rockets, both of them, and continue on that sort of be able to drop a rover off and that sort of thing. So that one seems to be on solid ground, and it's ULA. They've got a lot of customers. So that one excites me just because it's a workhorse, a high energy workhorse rocket. What are your thoughts?
Yeah. I mean, ULA definitely knows how to launch rockets. But their sort of future is uncertain. We've heard rumors that someone's going to, they're trying to sell ULA to some other provider. And fundamentally, the Vulcan rocket with the Centaur upper stage is like the Ariane 5. This is a largely disposable rocket system. They're going to try to reuse as much of it as they can in this sort of iterative phase. So they'll start by they'll eject the engines, and then they'll use a kind of bouncy castle to recover the engines from space. And then they can refurbish them and put them into new rockets, and the engines are the most expensive part of the rocket. And so they're going to sort of find their way to reusability in bits and pieces. But if Starship just works, then it just clears the field. because it is a fully reusable two-stage rocket. There's nothing fancy. It launches enormous payloads into space, and every part of it gets reused. So I think a lot of the companies, ULA, Ariane, even NASA with the SLS, they're assuming that SpaceX won't be able to figure this out, won't pull this off. And I don't think that's the right direction to take. I think you need to come up with you need to go where the ball is, as Wayne Gretzky said, right? I skate where the puck is going. And SpaceX seems to be the only company, apart from maybe Rocket Lab and some Chinese companies, who are skating where the puck is going.
Yeah, Rocket Lab's interesting. I actually interviewed the CEO recently, and I'm watching that very, very carefully, what they're doing, because, these go big, but you can also go small. And
totally, there's a launch market for that medium-sized provider when you want your mission to go to the right place.
Absolutely, and in this age of miniaturized CubeSats, I'm like, that's going to be big. What's your view of the future of CubeSats and miniaturizing satellites? And will there be a universe? Are you going to launch, when Elon drops the launch cost to $75 a kilo?
Totally.
Are you going to launch a universe today spacecraft?
Absolutely. Yep. Yeah, I already know what the plan is. My like 10 years ago, I thought about this, and I thought, like, what would be the coolest thing we could put in orbit? And that would just be a spacecraft that was live streaming a view from space sort of off to the horizon. And so you could just see like the horizon of the Earth and some stars in the sky, but also the Earth down below. And you could just leave it on as your background while you're at a party. And it would just show the Earth rotating under, or, orbiting below you. And so that's if it's $75, I can pay someone $1,000 to build my satellite, my cell phone camera with a solar panel, put it into space, done. I can't wait to do that. Yeah, the CubeSats are great, and the level of miniaturization that is possible in terms of the sensors, as well as even there's these really clever techniques for propulsion systems and orientation systems. Like, you can have a wire, you can run a charge through the wire, and that will make your CubeSat align itself with the Earth's magnetic field. And so you can actually change the direction that your satellite is facing purely by running electricity through a wire, which is really clever. You don't need thrusters. And so I think there's going to be a certain level that miniaturization is going to get us. The problem is that once you get farther and farther away from the Earth, you need a fairly beefy transmitter to be able to send your data back home. And a beefy transmitter requires a beefy solar panel system, or some, and batteries and radiators and all of that kind of stuff. So for stuff in low Earth orbit, I think CubeSats are a game changer. For getting away from Earth, we're probably still going to need pretty beefy satellites.
Fraser, if you had a cell phone camera in orbit, the Fraser CubeSat, and it was showing 24/7 Earth footage, I would dedicate an entire television to just that, running in the background.
Yeah, exactly. That's the plan. The plan is you just leave it on. It's always live streaming, and you're just watching the Earth pass underneath. And maybe two cameras, like one that's looking off to the horizon and one that's looking straight down. And you just run it live forever.
You want to get really cool? How about this idea? Put one in orbit of Mars, and you have a however many minutes delay, which varies, of course.
But then you're back to the transmitter problem.
Yeah, that's
right. So now it can't be a CubeSat. It can't be something that piggybacks off the Starlink network. It's something that has to have a pretty beefy transmitter. So I think we're not going to see that kind of technology work until we get more infrastructure into the solar system. That if there is a Starlink network at Mars that is gathering up, that is communicating with CubeSats in orbit around Mars, and then packaging it up and sending this big transmission back home along these backbones, then that's a game changer. But we're nowhere, right now that doesn't exist. And so again, we'll know we're entering that sci-fi future when we have that kind of infrastructure played out across the solar system.
Now, something a little bit more fresh in your memory, because you were just, as we were talking off air, you were just working on this. Speaking of the Ariane rocket, its most impressive launch I ever saw was James Webb. And that telescope is now at 2 years of functioning and collecting data. Give us a little bit of an overview of the best of JWST for the last year.
Wow. I'll grab my notes. We just, as you said, we just wrapped up recording our year 2 episode on James Webb. So what were all the big discoveries that were made during the year? So I'll give you like the highlights. So the first one, and I'm sure you reported on this plenty as well, is this discovery of jumbos, these Jupiter mass binary objects that were found in the Orion Nebula. And so, it had been hinted that these things were there, these rogue planets free floating through the Orion Nebula, and they've been seen by the Hubble Space Telescope and other telescopes. And then they turned James Webb on the problem, and it's the perfect telescope to do this because these things are Jupiter size, Jupiter mass, but they are, warm. They're not necessarily going to be like bright like stars. And it was able to find 540 of these objects in the Orion Nebula, and even more bizarre, dozens of them were in binary pairs. And so you've got 2 Jupiter-sized objects, or even down to like Saturn-sized objects that are in orbit around each other. And the question is like, how do you get that? Like if they're all individual Jupiter-sized objects, then it makes sense that during the early formation of solar systems, you have weird 3-body interactions. They're getting kicked out into the rest of the universe. But the fact that you're getting them in pairs makes you say, okay, well, wait a minute, maybe now instead, if the kinds of chunks of gas and dust that are spinning out and forming stars, maybe you get smaller versions of that are turning into like little Jupiters, as opposed to like a brown dwarf or even just a major sized star. So this has been like paradigm changing in our understanding of the contents of the cosmos. That when we look out into the night sky, we see all of these stars, but in fact, what we don't see could be just as numerous. And for me, I find it really exciting, really intriguing that there are these rogue planets that are drifting around us, and they could just be a fraction of a light year all around us in all directions. Like there could be 1 rogue planet per regular planet, but there could be 100 rogue planets per regular planet, and we just don't know yet. So we're kind of moving in that direction. So that was big. The other big thing that we got sort of at the other end of the spectrum was one of James Webb's big questions that it was trying to answer was, what was the answer, what caused the age of reionization in the universe? And so if you kind of go back to the very beginning of the universe, you have the cosmic microwave background radiation. This is that last light that was able to escape, or the first light that was able to escape into the universe. But then after that, everything was still cold and dark. Essentially, the entire universe was just giant clouds of hydrogen and helium left over from the Big Bang. And yet we know earlier on in the universe, we can see these first stars, these first galaxies start to form. And there was this time when the universe went from being dark to being lit up. And they call this the epoch of reionization. And the big question is, what was the cause? Like, was it the first stars going off, detonating as supernova? Was it supermassive black holes with quasars that were blasting out material that was heating up this gas and material that was causing it to start to shine? Was it, the first galaxies that were starting to heat this up? And Webb was able to use gravitational lensing, so it used galaxy clusters as natural telescope lenses to magnify the view to other more distant objects. And it was able to realize that the source of the ultraviolet radiation that was heating up the universe was dwarf galaxies. And so in fact, the dwarf galaxies were pumping out surprising amounts of ultraviolet radiation. They were filled with giant hot stars blasting out ultraviolet radiation that then heated up all of this interstellar gas that began this epoch of reionization. And this is like a big checklist item that just got checked off thanks to James Webb.
It has to be said that that telescope has just provided nothing but surprises.
Totally.
So far.
Yeah.
I mean, I could not have imagined the success of this telescope beforehand, even knowing about it.
Yeah.
What it was capable of. It's just that where it turns, it finds a surprise.
Yeah. Yeah. And then, there's a bunch of these things that are going to be broken. So it found the most distant galaxy. It found a galaxy that's at redshift 14, which is something like 290 million years after the Big Bang. And it was able to do 10 hours of observations, spectroscopic analysis, was able to really dial in that, yes, we're seeing this galaxy as it looked that early on after the universe. And then there's like these tantalizing hints of the first stars in the universe. You're not seeing necessarily the first stars, but there are pockets of gas and dust in the outskirts of galaxies that is primordial, like the conditions of the early universe, and it's seeing the kinds of stars that are forming in these primordial areas. So I would say those are the big ones, but I mean, we got the first potential sighting of a Haitian world, which I'm sure you've talked about, and the potential for dimethyl sulfide in the atmosphere of this world, which is a potential biosignature. So, maybe some giant water world with mats of phytoplankton pumping out dimethyl sulfide, or it could be a lava world, or it could be a mini Neptune. Like, the jury's still out. It goes, and then just the pictures. I mean, just, in the last year, we got the first Webb image of the Crab Nebula and the first image of the Ring Nebula and M51, the Whirlpool Galaxy, and the Horsehead Nebula. So we got some of the greatest images ever taken, got the Webb treatment. All of the ones that you've got on your wallpaper right now, the pillars of creation, you can just replace them with the Webb version and be really happy with it. Yeah, what a year. It was so hard. The hard part was that we had about 70 stories that we had to filter down to about 30. And we have probably got 200 or 300 that we've covered in the last year on Universe Today. And that's me filtering down thousands of potential stories that I'm seeing in all the different, research journals and press releases and all that kind of stuff. I mean, it's just a third of our news is coming from James Webb now. It's crazy.
Well, the other thing is that it's hard to keep up on it. I mean, I do the same thing you do. I look at the journals and, all of that stuff. And you miss a day,
Yeah.
And there's so many proposals. You look at the proposals for Webb. I mean, there's just so much. But what interests me is that last summer, around this time, around July and August, it imaged Tabby star,
yep.
KSE 8462852. And we haven't heard back yet. Have you heard anything on that?
No, I haven't. So the two gaps are Tabby star and TRAPPIST-1D. So we got the TRAPPIST system. These are 7 Earth-sized worlds orbiting around a red dwarf star. At least 3 of them are in the habitable zone where liquid water could be present on the surface of the planet. We got observations from James Webb for the first 2, B and C, which were inside of the habitable zone, so they're too hot. And so it was hoped that they would be super Venuses. And unfortunately, very carefully, Webb found no presence of an atmosphere on either of those worlds. So it's more like super Mercuries is a better example of what these worlds are. But the hope is the TRAPPIST-1D does have an atmosphere. And the data have been taken in the same way the data have been taken about Tabby star. And somebody out there knows the answer to this question and yet is being extremely careful about how they're processing the data to make sure that they provide as unambiguous a result as possible. Because the second anybody puts their neck up and goes, we found an atmosphere on TRAPPIST-1D, or we did not find an atmosphere on TRAPPIST-1D, then people are going to lose their minds. But the gist that I'm getting, I've talked to enough scientists. I'm like, do you know anything about TRAPPIST-1D? And they're saying, no, I don't know, but it is kind of surprising it's taking this long, and it really feels like these worlds are very hostile. I don't think we're going to find atmospheres on planets orbiting around red dwarf stars. But that tells you something right there. Because if you can look at TRAPPIST-1D and say this doesn't have an atmosphere, and you can say it definitively, that tells us a ton about red dwarf systems. Yep. That really takes them off of the normal surface habitability potential, right? That's exactly right. They go from, and it's going to take a while before people finally give up on them and go, okay, fine, we've imaged 20 of them and we haven't found a single atmosphere yet. They suck. Okay, move on. And then all eyes are on the Habitable Worlds Observatory. But until then, I mean, these are the kinds of planets that Webb is capable of imaging. And so we have to wait for that kind of data. And so I think the same thing is probably happening with Tabby Star, that the data have been gathered, and the people who put in the call have their year of time with Webb to study it and to crunch the data. And when they go live with whatever is the result they've had, they want it to be as well researched as possible. They want to really play out the clock to make sure they do the best job they can.
Strangely, and this is a little corner of this, they waived that. So that data is out there for anybody. And
okay.
yeah,
Well, then, but anyone can go and grab it.
Nobody's looked at it. I haven't seen anything on it. And all I want to know out of it, all I want to know is, did it see infrared light? Did it see glowing dust?
Yeah.
And there we go. And if it doesn't, that's going to be strange. But I know from that star's history, that it likes to be strange. So who knows? Yeah.
I think that star has kept you up at night a lot.
It has kept me up at night since 2015.
Yeah.
Well, it's just that it's curious because it's a mystery, and I was
either way.
Yeah, either way.
Yeah.
But I have a sneaking suspicion, again, it's a surprise, because if you remember the original paper on that star by Boyachin and colleagues, posits that cold comets shattering might produce this. And that's a really interesting thing that could be happening out there. Just an enormous hail of comets all colliding with each other, careening towards a star is pretty cool in and of itself.
Yeah, there was one story that we reported on that was really interesting last year, where Spitzer Space Telescope had originally imaged a star system, like a newly forming star system, with a lot of dust in the star system, and astronomers said, like, this might just be that everything is newly forming and you've got all these small dust sort of rocks that are grinding together and producing all this additional dust in the system. But the more exciting possibility is that it's asteroid, like two planets crashed into each other and generated a bunch of dust. And so then astronomers came back with James Webb just last year and imaged the system again, and they didn't see the dust. And so, in fact, Spitzer did see asteroids collide into each other, producing all this dust.
Pretty crazy, the amount of collisions that are going on out there. That seems to be a lot higher than what we used to think. That, planets hit each other, and they can do it relatively for a long time.
Yeah.
And actually with Spitzer, there was a huge infrared flash back in the 1980s, or it was IRAS, actually, rather IRAS. And they got this huge infrared flash that lasted about a year inside of a protoplanetary disk, and it appeared we just happened to catch two planetesimals colliding way back when. And that really seems to be a common thing in the universe, which makes me wonder about the Fermi paradox, because if you've got so many collisions and hails of comets and all that stuff, well, the solution might be we live in a calm star system.
Yeah. Well, and back to that thing about the jumbos, right? That you're seeing all of these planets that have been kicked out of their systems. Does it mean that the solar system started with dozens of planets and has booted most of them out into space? That the early solar system might have been a lot more chaotic and dangerous than we thought. Or even, as you say, maybe we are surprisingly calm, that we're one of the lucky ones, and that might give another reason why life got a hold here when it maybe had a harder time in other places.
I think with the jumbos, though, the interesting thing about rogue planets, as you alluded to and touched on, was that they could be close. Mm-hmm. I mean, we could have planets from an entire different star system coming to us, meaning that, okay, so say we're stuck here and we can't really go to Alpha Centauri, it's just too hard and all that. But we can go look at an alien planet.
Yeah.
That's not from here, possibly. And that to me is really interesting because, well, first of all, the geology would just blow me away of, a planet that didn't form here. Isotope ratios and everything else that goes with that. But I think that was, as far as the failures of sci-fi and sci-fi producing tropes, that was one that went the opposite way, because we used to think, oh, you got to jump in and use your warp drive and go, halfway across the galaxy to find a planet. to examine. Whereas now we know all this stuff comes here.
Yes.
And we know this from interstellar objects that flotsam and planets potentially pass by all the time, and stars do too occasionally.
Yeah, by the time people are watching this, we will have released an interview that I just did about interstellar objects and sort of what is the state of the art of our understanding. And the estimate is that there is one interstellar object currently in the solar system within every 10 cubic astronomical units. And that when you measure out to the orbit of Neptune, that gets you about 10,000 interstellar objects. So the current estimates is that there are 10,000 interstellar objects of varying sizes within the orbit of Neptune in the solar system, not to mention like out to the Kuiper Belt, out to the Oort cloud. I mean, there are going to be potentially millions of these objects in our solar system that have been sent on these journeys from other star systems. And so for the longest time, we thought we had to go to other star systems. But as you're exactly right, turns out the universe was just throwing all this material in our direction, and all we had to do was find it.
Yeah, so we don't have to necessarily, to look at something alien to our star system, we don't necessarily have to go to another star system. We can do it here, and we can do it quickly. And there are also captures. There are two, they're thought to be former comets, exocomets, that Jupiter seems to have captured. So they're sitting there captured,
Yeah, ready for study.
Ready for study. So that's going to be over the next 50 years, that's going to be big news that we can actually study material from other star systems without having to go to them. Fraser, we're almost out of time, but I got one last question for you. I've seen the Aurora Borealis 3 times in my life, and the first 2 were underwhelming. One was through an aircraft window. One was just a very dim red glow, I think during the 2003 coronal mass ejection. And then this year, which blew me away, because even at my very southern location, it was blazing directly overhead and covering over 1/3 of the sky. And I could see color. I could see the banding, the green. I could see red, and shimmering, constantly changing white. And it was just absolutely amazing. Tell us your Aurora story, or lack thereof of one.
Yeah. So I went to Japan with my son. This was a trip that we've been planning. We were originally supposed to go back in 2000, and then COVID. And so we rescheduled it for spring 2024. And we left at the beginning of May. We were there till May 15th. And that was right in the middle of that was when that Aurora storm hit. And so I was in Kyoto, in light polluted Kyoto, and I went outside and tried to find a reasonably dark place, and I watched the sky, and there was like a light cloud cover, and I couldn't see anything. Now, my wife, back home in Canada, in our perfectly dark skies, far away from civilization, she was sitting on our driveway. She said she was out there for like 5 or 6 hours, and it was just the most spectacular sky show that she had ever seen. And she recorded just amazing pictures from her iPhone that are better than, the kinds of stuff that you see in magazines sometimes. Then she was just sitting there just going like, yep, it's all coming to me. So no, I missed this one. But we have not reached solar maximum yet. We're still about a year away from solar maximum. And so things are just going to get better from now until next year. And then we have a couple of years of coming down the backside of the solar maximum. So the thing that I always tell people is find some kind of Aurora Alert app, install it on your phone so that you get a notification when there's a lot of activity happening. You've got a good chance of seeing an aurora. Go to a place where you have nice dark skies. You can see the aurora to the north if you're in the northern hemisphere, to the south if you live in the southern hemisphere, and take your chances that most likely you won't see anything. Most likely you'll just see this pale red glow, but there's a chance you'll see something like what John saw, what I've seen in the past, and what my wife saw. So it is definitely a life list, kind of bucket list thing to see.
And it was fantastic. Thanks again, Fraser, for visiting with us. And I look forward to next time. And we'll check in and
no problem. Always fun
about all of the developments in astronomy, which keep coming so fast that It's hopeless. And if you monitor a bunch of areas of science like I do, the archaeology and it's just I work 24/7 and I can't take a vacation ever.
Yeah, I wouldn't have it any other way.
Anna, why is the possum sitting on top of a large rock being dragged across the lawn by harnessed squirrels? And hey, look at him, he's dressed like an Egyptian pharaoh. Who paid for that costume?
It's his new construction project, John.
Well, what's he building?
It's an astronomical tool, John. A henge.
Well, like Stonehenge in that weird country where everybody strangely sounds like you?
Yes, John. Look, he's nearly finished.
Oh, all right, so what kind of astronomical observations is he going to do?
It's uncertain, John.
Well, I just have to consult someone, and I have the perfect person. Fraser, you know anything about henges?
I do know about hinges, and from what I can tell, it should be aligned to the sun so you can mark the seasons. John, this henge is not aligned to the sun.
Yeah, he's deploying some kind of a it's a laser.
Targeting notice.
It's laser henge, and it's focusing the laser and shooting at me. I no longer have safe free access to the yard. This violates the treaty.
Things are so much more peaceful on my channel.